Hello everyone. As we are revising our NCERT 11th standard, including both the text entitled Fundamentals of Physical Geography and India Physical Environment, now I am dedicating this particular video to the exogenetic forces. One part we have already discussed, river as an active agent of gradation. I want to rope in two agents now from our fundamentals of physical geography: groundwater as an active agent of gradation and glacial effectivity. When I talk about groundwater, there are certain important terminology. We have got a very brief mention in NCERT, it's not in details, that we should be aware of, so I'll be adding that. And when we talk about glacier as an active agent of gradation, again there are certain mechanism and also terminology that goes with glacial action, that also will be adding. And as we always do, combining the content matter of NCERT with few selective diagrams to make the things easier for our understanding. I hope we are taking the revisions with the reference of these videos. Let us get to our two effective agents of gradation one by one: groundwater and glacier, moving mass of snow and ice as an active agent of gradation. In our continuity of the study of chapter 7 of 11th class NCERT, landform and their evolution, we are now picking up groundwater, and NCERT very clearly gives us one interesting statement in the beginning. Here the interest is not on groundwater as a resource. Our focus is on the work of groundwater as erosion of landmass and evolution of landform. So we are talking about underground water as an active agent of gradation. Then comes up very important statement, numbering it. The surface water percolates well when the rocks are permeable, thinly bedded and highly joins or cracked. So when percolation takes place, then only we'll have the development of underground water, and I require that underground water for the effective development of landform features. That is the reason, jumping here, the results of the work of groundwater cannot be seen in all the types of the rocks, but in the rocks like limestone, dolomite, rich in calcium carbonate. Remind yourself, they both are examples of sedimentary rocks. And which category of sedimentary rock? Non-clastic. We have already discussed in details the study of rock types. The surface water as well as groundwater, through the chemical process of solution, precipitation, deposition, develops variety of landforms. And we have to learn these landforms. But the first and the foremost thing that we need to study when we talk about groundwater, what is meant by aquifers? What is the involved geology of the groundwater? And then we talk about the developed features. We'll be coming back to NCERT. First we are picking up the support of some diagrams to understand on the features carefully. Now what are the terms that we should be aware of when it comes to the groundwater regime? So groundwater regime gives me certain important terminology that includes Vadose zone. Vadose zone is unsaturated zone. And try to remind yourself that this is the zone where we have maximum of our karst topography development. Vadose zone can be applied as this zone in the diagram, which is not having water table to it, or it is overlying the groundwater table, where we have efficient percolation taking place. When I talk about the phreatic zone, I talk about saturated zone. And with saturated zone, we use two defined terms, both of them related. And saturated zone basically goes with aquifers. Now with aquifers, what exactly we take into account is, number one, unconfined, that are shallower, of course cannot be a watertight compartment, and confined, that is comparatively deeper groundwater table. Are we noticing confined aquifer and unconfined aquifers here? This doesn't complete. So what we have to add? The unconfined aquifer lies between Weddow's zone and equitard, new term, whereas confined aquifer is largely confined between equitard and equiclude. Read these terms in the diagram. How do I distinguish between them? Equitard is permeable and equiclude is impermeable. In addition to this, what is the important terminology that we should be aware of when it comes to groundwater regime? This diagram is showing us recharge. So if I am talking about recharge, don't miss to see equitard in the figure and also the spring. Recharge will be percolation. If it is percolation from rainwater or running water as is seen here, that means external agent. Then which type of recharge area it is called? It is called allogenic. What is allogenic? Allogenic is something that is coming from external sources. So recharge area can be allogenic if it is external, and will be autogenic. See, this area is being marked up as autogenic, where we are having solution on the surface leading to percolation of water, and this percolation of water is generating the underground water conduits. So autogenic will be by limestone itself. And I am repeating, the recharge areas are classified into two. What are allogenic recharge area? The allogenic recharge area is when the percolation is involving rainwater or it is running water, and it is distinguished from autogenic recharge. Autogenic recharge will have recharge from the karst by itself. So the terminology that we have learned so far includes Weddow's zone, phreatic zone, recharge area, unconfined, equitard, confined. Going back to NCERT. Any limestone or dolomite region showing typical landform produced by action of groundwater through the process of solution and deposition is called caste topography. So what we are willing to learn? Caste topography. What is caste topography? Caste topography is underground water as an active agent of gradation. Will it be only underground water? No, it can be also the surface solution. Caste topography includes erosional landform. This is our block number 1. And NCERT reads pools, sinkholes, lepees and limestone pavement. We want to learn each one of them one by one. And the brief definitions are also given here. We will be taking these definitions as our support one by one in terms of understanding the things carefully. So caste topography with surface solution A includes pools, sinkholes, lepees and limestone pavement, and once it becomes underground water, right here, once I am talking about underground water, that means I am no longer on the surface. Then B, we develop karst caves. So we are dividing erosional features of karst topography as, writing it boldly here, surface feature and subsurface feature. And we want to learn these erosional features, surface and subsurface, with support of easier diagrams. If I have to talk about surface features, I'll essentially talk about pinnacles. I hope you are noticing these pointed pinnacles that are developed due to some erosional solutional hollows called clefts. So what exactly is pinnacles or pinnacled topography? We call it lepes. This figure is showing us lepes, and what lepes are showing us? Lepes are showing, if I just try to make it sort of three-dimensional figure, can you notice it is actually these erosional or solutional hollows that have been created. So what exactly these pinnacles are? These pinnacles are left out part of limestone when the rainwater, falling raindrops have eroded or dissolved some part of limestone on surface, and this dissolving is creating clefts. Clefts can easily be referred as narrow solutional hollows. So pinnacles and cleft combines to make what is called lepes. Lepes feature number 1. And once we talk about this feature, slightly zooming in, please have a comparison. There is always the comparative terminology that comes into forefront, and that is called clints and grikes. Are they similar to that of pinnacle and clefts? Actually not. In the bedded rock with joints, continuous rainwater will do what? It will enlarge these joints. Stagnation of water will result into enlargement of these joints. These joints enlarged will be called variable sized basins, grikes. Can you notice them here? These all will be grikes, and here goes my underground water. And these flat topped boxes are called clints. So what are the points that we can see as a difference between the surface solutional features? Lepes have pinnacle and clefts, which is very different from clints and grikes, because clints and grikes are with joint rock strata. We are talking about surface solution. Which are the features that are developed by surface solution of karst region, limestone region? These includes lepes and includes clints and grikes. Very common mistake we do. Grikes are not similar to cleft. Cleft can be both narrow or broad. Grikes are normally broader, segregating more or less horizontal boxes, which is nothing but the joint rich strata of limestone. If I have to talk about other surface features, we have got these features as dolines or sinkholes. It is written twice in the figure. And we also have limestone pavement. This is also mentioned in our NCERT. And a sinking stream here. Why this stream have started shrinking in? Because either it has dissolved the area or that there has been the collapse of it. So basically when we talk about surface solutional feature, we talk about sinkholes, doline, ualas and polias. These basically are variable sized surface solutional hollow, and they can be arranged in terms of their size, in sense that I can say sinkhole is the smallest and polias are the largest surface solutional hollows. And how do we distinguish them when it comes to the previous set of features like Lepes or the feature that we have related with the development of clins and grikes. It's basically that I am talking about a more or less jointless strata. Rainwater stagnation is generating some sort of solutional hollow, a raindrop dissolving, accumulated water dissolving. That is how we demarcate these solutional hollow features. And how do I take definition of limestone pavement? Limestone pavement is non-dissolved area. Let us read it from NCERT. It reads, gradually most of the surface of the limestone is eaten away by these pits and trenches, leaving extremely irregular with a maze of points, grooves and ridges or lepes. Lepes we have learned. Especially these ridges or lepes forms due to differential solutional activity along parallel to sub-parallel joints. The lepy field may eventually turn into somewhat smooth limestone pavement. I created lepes. These were my lepes with clefts. I hope you have taken it. And in due course of time, what will happen? It will generate a near smooth leveled feature, and that is called limestone pavement. Going back to the diagram for us to understand it. If I level it out in due course of time like this, and I give it a three-dimensional look, almost like this, will it be some irregular surface more or less leveled out? That can be called limestone pavement. And there will be nothing wrong for us to say, slightly zooming in, that limestone pavement can be correlated with such joint-rich strata also, which develops clint and glike. Limestone pavement. And what are the surface solutional features? Sinkhole, doline, uvala and poly in increasing order of size. And any of the solution, if we are enlarging it and moving underground, by default will create some subsurface solutional hollows. We are underground now, and these subsurface, do notice this is my water table. So if this is my water table, what is the term applied to it? Aquifer. Where we are developing entire underground water feature into, what will be the term applied here? Yes, Beddoes zone. So underground water, which we labeled as part 2 to our study in the limestone or karst topography, goes as Beddoes zone. It can be phreatic zone, but largely Beddoes zone. And the Beddoes zone formation, cave formation, karst cave formation is the outcome of solution without any doubt. And the term that is being highlighted here, speleotherm, is all the cave deposits. Each one of them is calcium carbonate deposits. So what is karst cave? Karst cave is subsurface hollow. And what is speleotherm? Speleotherm is all cave deposits. And how many types we recognize here? The commonest types of cave deposits recognized includes pinnacled deposit, stalactite, ground deposit, stalagmite. And we can have these stalagmites growing with stalactite to become coastal or the karst pillars, column. So what are the features that I take as underground water as erosional feature? So underground water as an erosional feature will be developing surface solution, we were having sinkholes, we were having dolines, uvalas, and this is my subsurface solutional hollow. This subsurface solutional hollow will be called karst cave, and within this cave all the limestone deposits are speleotherms. What are the common speleotherms? Stalactite C and stalagmite. Why I have highlighted G and C? Because stalactite is from the ceiling, stalagmite is from the ground. NCERT. A we have done. We are now talking about caves. The areas where there is alternative beds of rocks with the limestone and dolomite in between, or in area where limestone are dense, massive and occurring as thick bed, cave formation is prominent. Water percolate down either through the material or through the cracks joint, move horizontally along the bedding plane. It is along these bedding plane that the limestone gets dissolved and the long, narrow or wide gaps called caves result. Caves having opening at both the ends will be called tunnels. It basically comes out to be very obvious kind of terminal. And if I continue to read NCERT with the depositional feature, that is our feature category number 2, erosional was our number 1, we divided it into 2 categories. What is depositional feature? Depositional features include stalactites hang, stalagmite rise up. The stalagmite forms due to dripping water from the surface or through the thin pipe of the stalactite immediately below it. Stalagmite may take shape of a column, a disc, or either a smooth rounded bulge end or a miniature crater-like depression. Why depression? Because it is from ground. And when the stalactite, stalagmite eventually fuse, they give to the rise to column or pillars. Which features are these? These features are called speleotherms. And how many speleotherms we have in the karst cave? Essentially 3. Stalactite, stalagmite, pillars. Stalactite, stalagmite, column or pillar. Picking up next agent, glacier. Masses of moving sheets over land, continental glacier, Piedmont glacier, or as a linear flow down the slope of the mountain or valley glacier are called glacier. So simply have the definition. What are glaciers? Glaciers are moving mass of snow and ice. And this moving mass of snow and ice can actually be 2 types. Which are they? Our NCERT clearly reads, either it can be continental glacier or it can be the valley glacier. We can also call it mountain glacier. So valley glaciers or mountain glaciers and continent glacier. Continent and valley. In any mountain area or the area where there is availability of slope, there will be the movement of snow and ice. Until and unless this movement is there, I cannot call it glacier. So movement is essential. So please take the terminology. More snow, equilibrium line, less ablation. I have used this term earlier. Ablation is melting process of ice. So nutshell, in this particular area, I can see the arrows being marked up in the diagram. In this particular area, we are having more supply than melting. So automatically mass of snow and ice is getting accumulated, which tends to develop gravity process related advance. This facilitates moving mass of snow and ice, and that is called glacier. So, glacier correlates with the areas which has got higher availability in terms of precipitation compared to. So, I am writing snowfall is greater than ablation. Automatically what will happen? There will be thicker mass of snow and ice, and that will facilitate the gravity transfer, generating glacier. So, what is the way the glacier marks up its genesis? Input is snow and rain. This will be my snow field. Accumulation of glacier will facilitate movement of glacier. Movement makes it act as agent of gradation. Because it moves, it tends to grade, and this grade correlates with several processes of plucking, abrasion, ablation, accumulation and transportation. Gradation means what? It will erode, it will transport and it will deposit. I have already told you ablation, read it here very clearly, is melting process of ice. So, snow field is that area where there is accumulation of snow and ice. Accumulated snow and ice, when start moving down the slope, it tends to act as gradational agent, glacier. This glacier is engaged in all the threefold tasks, and as written in this diagram, output will be melt water, which we can easily call streams, and moraines. What are they? We will be learning it in the next go. In NCERT, erosional features developed by glacier include cirques. It also includes horn and ridges. How do we take the understanding between these and how we segregate it? We are trying to learn them, each one of them, but taking the definition, cirque is the most common landform in glaciated mountains, and horn forms through headward erosion of cirque wall. If three or more radiating glacier cut headward until their cirque meet, high sharp pointed steep sided peak called horns are formed. So, basically cirques, horns, they correlate to each other. Let us understand it with this, we will come back to diagram NCERT. At this point we are experiencing freeze and thaw weathering. Steeper slope is facilitating plucking, scooping. Rotational effectivity is creating abrasion, and this abrasion is, so we have got the broken rock material, scooping, plucking and abrasion here. If I ask you to imagine this to be the original slope of the mountain, because of the combination of freeze thaw, plucking and abrasion, there has been the continuous retreat of the wall. This wall has retreated. This steep standing wall and a deep depression that is developed here is called cirque. What is cirque? Cirque is erosional feature developed by a glacier which involves the combination of freeze-thaw weathering, plucking or scooping as well as abrasion. And the shape of cirque is such that we call it armchair topography. Notice the same here. It's all covered with snow and ice, and I am purposefully highlighting it. These gaps on the ice surface is called Bergkurrent. This is steep back wall which is experiencing what? Freeze and thaw weathering. What is taking place here? Plucking. What is the action that we are having here with rotation? Abrasion. And thus which type of feature is getting developed here? The armchair topography. And this armchair topography is called cirque. And don't miss to see these cracks on the ice surface wherever the gradient changes. See this figure now. If this depression developed in the mountain wall due to the plucking, the features that we have talked about, freeze thaw, plucking or scooping, and abrasion. This depression that we are noticing right here is the depression that is called cirque, and I can see another adjacent depression here. So if this is my cirques right here, the wall that separates two cirques are called arete, and the peak that thus gets modified of its slope is called horn. So the features are interrelated. What are the features we have just learned? It's cirque, it's arete, and its horn. What are cirques? Cirques are the depressions that are generated due to plucking, rotational movement, and also abrasion. And whenever we take the reference of these cirques, they will be automatically generating arete. Aretes are those left out mountain wall which is segregating two neighboring cirques. And if we develop more than one arete on the mountain slope, we'll automatically develop horn. Added to it, we can also incorporate the broader glacier valleys, tributary valley, main valley. The other feature that we correlate with glacier as an effective agent of gradation includes comparatively less in gradient, segregating broader, much broader glacial valleys. So glacial troughs are usually U-shaped valley. If you just try to combine it with what we have learned with river, and it always associate with hanging valley. What exactly are these features? Let us take it with this diagram. Glacial trough, truncated spurs, tributary valley, so what is tributary valley called? Hanging valley. And lower main valley, you call it U-shaped valley or you call it glacial trough. And what is this truncated spur? Truncated spur is the steep standing wall of the main U-shaped valley. So comparatively less gradient area. How do I distinguish between cirques and that of U-shaped valley? Cirques basically are in the steep slopey areas. Please have a comparison with support of this figure. Cirque, arete, horn, main valley, hanging valley. What will be this? Truncated spur. What are these? Aretes. What is this? Cirque. And what is this? This is spur, truncated spur, that is segregating one hanging valley and the main valley. And all these lakes that you are noticing, Tan specifically mentioned in our NCERT, is also the lake that is correlated with what? It is lake that is developed in cirque. So during summers when the ice melts, I can have accumulated water in the water filled depressions that can be called lake. And coal here, I can have the lakes right here also. So lakes can also be called ribbon lake. Ribbon lake is largely with troughs. So these are associated features. Glacier valleys and troughs. Glaciated valleys and troughs are U-shaped with broad floor and relatively smooth and steep sides. There can be hanging valleys at the elevation on one or both sides of the main glacier valley. The very deep glacial trough filled with sea water making shoreline at high altitude are called fjord or fjords. And when we talk about the Norwegian shoreline, it's essentially the example of fjord shoreline. So how do we correlate glacial trough and fjord shoreline? We simply say the sea invasion on U-shaped valley will be fjord. So by default it will be with the higher latitudinal areas. Then NCERT talks about depositional features with moraines. The unassorted coarse fine debris dropped by melting glacier is called glacial till. But this is not sufficient because there are different shapes and size that they develop. So we want to learn it with this diagram. Horn, errate, cirque, errate, cirque. Glacier descending down the slope starts depositing in its melting process. Whenever the melting deposits of the two descending glaciers join in, they will develop medial moraine. So moraine are the common deposits that are categorized on the basis of their location. So don't miss to see the names here. What are lateral moraine, which are at the sides of the glacier? What are medial moraine? The central ones. And what are end moraine? End moraine where the glacier terminates. It melts. And whenever we talk about end moraine or terminals of glacier, we do talk about certain important terms. Like we can see recessional moraine. What is recessional moraine? If terminal moraine is this, then how do I distinguish it with recessional moraine? So you need to understand that there is always a seasonal variation in sense that terminal moraine will be the higher extension typically confined to winters, and recessional moraine when the glacier will melt faster essentially during summers. And don't miss out to see these streams and developing outwash. Glacial deposits, moraine. What are moraine? Unconsolidated debris deposit that is deposited by melting glacier. They are essentially classified on the basis of their location. And what are the categories that we have based on location? It is lateral to the side, it is medial to the center, and it is end at the melting point of the glacier, and outwash to be enlarged as. In the outwash, we develop range of features. And which are these features? The features includes drumlins. Drumlins are isolated blocks of the mounts that we can notice in this figure. How it is different from eskers? Eskers are continuous ridges. Don't miss to see the moraines right here, because moraines are considered to be the significant unconsolidated debris deposit. And these kettles, what are kettles? Kettle lakes are water filled depression. And all this is drumlins always incorporate this characteristics. Stoss and lee slope. Movement of the glacier is like this. Basket of eggs topography. Moraines are long ridges of glacial till, terminal moraines, lateral moraines, Interestingly, there is one more point which is given. Many valley glaciers retreating rapidly leave irregular sheet of till over their valley floor. Such deposits varying greatly in their thickness and in surface topography are called ground moraine. Do see this figure of NCERT? Continuous ridges of deposits, esker, isolated mounts of deposit, drumlin, the lakes that are developed due to water filled depression, kettle, and all this makes example of outwash. What will be this? Drumlin. Outwash plain, drumlin. This will be Stoss end, and that will be leeward side, the glacial movement. Medial moraine. Eskers. When glacier melt in summer, the water flow on the surface of the ice or seep down along the margins and move through the nodes of the ice. These water accumulates beneath the glacier and flow like stream of the channel. When these channels deposit very coarse material like boulder and block, the rock debris carried into streams settle in the valley beneath. This generates the ridge deposit called eskers. And what is outwash plain? The plain at the foot of the glacier mountain or beyond the limit of continental ice sheet covered with fluvio-glacial deposit. Fluvio, because you do have streams generated here. That is the reason we call them outwash. Alluvial fan, outwash plain can have gravel, sand deposits. Glacier as an active agent of erosion develops cirques, ereaths, horn, U-shaped valley, hanging valley, truncated spur. As agent of deposition, it develops moraines, drumlins, eskers, and outwash plain. Do take revision picking up these expressions. A question is being highlighted in NCERT. I am just encircling it to close down. What is the difference between till and alluvium? Till is glacial deposit and alluvium is river deposit. Whenever you try to revise these topics, you need to take support of different important figures. NCERT figures are also good, only that it do not give me that much of the explanation altogether. That is the reason we also follow Gochi Leong, which is nothing but much pictorial version of NCERT. So you can take that into your reference and do revise two agents. Now we are aware of three of them. River, the universal agent of gradation. Glacier, the moving mass of snow and ice with higher latitude and altitude. And also underground water as an active agent of gradation, as is related to limestone or dolomite region. Happy learning to all of you. All the very best.